Hello everyone, welcome to Mathematics Pashala. This is Naresh. Today I'll discuss this problem which came in CHR Net December 2023 in part B. Let's see the question. Let H equal to Z belongs to C such that imaginary of Z greater than 0 denote the upper half plane, and let F C to C be defined by fz equal to e to the power iz, then which one of the following statement is true? So let z equal to x plus iy. So imaginary of z is y, that is greater than 0. So if this is x axis and this is y axis, so imaginary of z greater than 0 means y greater than 0, that means upper half plane. Okay, now what is said that fz equal to fz equal to e to the power iz, that means to the power I into x plus iy. So that means e to the power ix minus y, that means e to the power minus y into e to the power ix. Now what is e to the power ix? E to the power ix equal to cos x plus I sin x. So mod of e to the power ix is what? Cos square x plus sin square x. So this is 1. So mod of e to the power ix becomes 1. So if I take mod of fz, we will get e to the power mod y, because this mod of e to the power ix is 1. So we know that e to the power minus y is greater than 0, because e to the power value of e is 2.7 something, so e to the power minus y should be greater than 0. So it will become e to the power minus y. Now it can written as e to the power y. Now e to the power y is greater than 1, so 1 by 2 to the power should be less than 1. Should be less than 1. So what we get, basically mod of fz is less than 1. That means fz is bounded. So now fz, mod of fz is less than 1 for all z belongs to h. For all z belongs to h, so mod of, so fh should be bounded. So because mod of fz less than 1 for all h, for all z belongs to h, so fh is bounded. So option 3 is true. Now see, in option 1 what is said? In option 1 said that fh equal to c minus 0, whole complex number, only 0 point is not there. Now you can see that 1 plus 2y, modulus of 1 plus 2y, 1 plus 2y belongs to a complex plane, so belongs to C. Now modulus of 1 plus 2y is what? 1 square plus 2 square, that is root 5, that is greater than 1. So 1 plus 2y not belongs to fh, since if z belongs to h, then implies mod of fz should be less than 1. Since 1 plus mod of 1 plus 2y greater than 1, so 1 plus 2y not belongs to fh, but 1 plus 2y is belongs to c. So here what is said that fh equal to c minus 0, but what we can see that 1 plus 2y not belongs to fh, 1 plus not belongs to fh, so it can't be c minus 0. So option 1 is false. So option 1 is false. In option 2 what is said that fh intersection h is countable. So what is fh? Fh is actual basically mod of fz less than 1, that means unicycle less than radius is 1. So like this, if this is 1, so this is basically fh. Now fh intersection h is upper half plane, so it will be upper circle like this. So what we know that unicycle is uncountable, so half cycle should be uncountable. So what is said here? fh intersection h is countable. So option 2 should be false because unicycle is uncountable. Here FH intersection H also should be uncountable. Any circle is uncountable. So this is the half cycle circle. So it also uncountable. So option 2 is also false. Now in option 4, what is said that FH is a convex subset of H. Let's see. What is convex set? If you take any curve to any 2 point, this line segment of this two point should belongs to that curve. Then this curve is convex set. Okay, then this curve is convex set. If you take any 2 point of this curve, the line segment should belongs to this curve. So if a curve look like this, then the line segment you can see that not belongs to the whole line segment, not belongs to this curve. So this is not convex. So here you can see that fz equal to, if z belongs to h, then fz equal to e to the power ix into e to the power minus y. That is not equal to 0. E to the power ix is not equal to 0, and e to the power I minus y is also not equal to 0. Therefore fz is not equal to 0. So 0, 0 point is not belongs to fh. So if you going to this curve, then 0.00 point is not belongs to fh. Now if you take this point, and this point, the line segment of these 2 points should be like this, but we can see that 0 point is not belongs to this curve. So the whole line segment is not belongs to that curve, because 0 point is not belongs to this curve. So whole line segment is not belongs to this curve. Therefore FH is not a convex subset of C. So option 4 is false. So only option 3 is true. Thank you for watching this video. Thank you very much.